Okay, let's try this again. So here's my example that I'm going to investigate the phase plane with, and it's the idea of the simple pendulum, where you just have a single mass m suspended by a rod of length L, and you've probably done this in physics, where just using vectors and Newton's second law, you can derive the second order autonomous equation ml theta double prime plus cl theta plus mg sine theta equals 0. And then you would have probably used the small angle approximation that sine theta is approximately theta to get a constant coefficient equation, which you can then solve. And the solution is a trig function. And if there's damping, it's a trig function times a negative exponential. Okay, so what we're going to do now is we're going to use maxima to investigate theta double prime plus c theta prime plus 5 sine theta, where c, of course, is the damping constant. So let me pause while we go to maxima. Okay, so here is the situation of pendulum, and it's the undamped case where c equals 0. So we go ahead and we, so this is how we do the command in maxima, plot df. So we're going to evaluate the cell. Okay, so let me see now if you can see that. Okay, so here is our phase plane. So this is the phase plane for the undamped pendulum. And if we click on a spot, that's like giving the problem initial conditions, and it will go forward in time and backward in time to give some sort of trajectory. So up here, it's something with, so we saw that so x was around -5 and x prime is around 5. So we've really given the pendulum a shove, and it's going round and round and round, and you can kind of see this. So x, remember, is theta, so it's going, here is 0, here is 2 pi, then forward will be 4 pi, etc. Okay, and so if we give it less of a shove, then you'll get a picture like this. And so that now you see the x is just going between some angle and some other angle, but it's not going round and round, okay? And we're not really seeing an ellipse, are we? That's what we would see if we were doing it with constant coefficients. And so if we go try it in between, we see something definitely more unelliptical like, and so what's happening here is we're using large angles, so the small angle approximation doesn't work, and so we're seeing something completely different from what we would see with where trig functions were the solution to the problem. Okay, so let's now go to the undamped case. Okay, so here's the maxima file, and so I've added the term -0.6 times y. Remember, y is x prime, so this is with a c of 0.6. And so if I go ahead and evaluate the cell, I get a picture which kind of looks, a phase plane which kind of looks before. Hang on, let me get it up for you. Let me just pause. Okay, I think I'm getting the hang of this. And so now you should see the phase plane. And it kind of looks like before, but what happens when if I click? So remember, if I clicked up here before, it would have just kept on going round and round. That doesn't happen anymore. Okay, it goes around maybe once, but then it gets kind of trapped and it goes to 0. So we're seeing the the damping, killing the oscillations, and it kind of doesn't kind of matter where we click, they all look kind of the same. Okay, notice the direction of the arrow. The direction of the arrow is coming towards 0. So 0. So notice here it doesn't look like 0, but remember it's in theta, so any multiple of 2 pi is actually 0. Okay, and so that is the pendulum.